We spent decades and $10 billion building the James Webb Telescope. The goal was simple: look back in time to the very beginning of the universe and confirm our theories. We thought we knew exactly what we would find. We expected to see a dark, empty void with a few small gas clouds just starting to turn into stars. But that is not what happened. As soon as the data started coming in, the astronomers realized something was wrong. Deep in the past, where there should be nothing but emptiness, the telescope found massive, bright galaxies. And I don't mean small clusters, I mean monsters. Structures that are as big and heavy as our own Milky Way, but sitting in a time period where they shouldn't exist yet. Here is why that scares scientists. Gravity is a slow process. It takes billions of years to pull gas together and build a galaxy that size. But these things existed just 300 million years after the Big Bang. The math simply does not work. There isn't enough time in the universe for them to be there. But they are there. This means one of two things. Either our equipment is lying to us, or the history of the universe is completely different from what we thought. And if the history is wrong, then our understanding of reality is wrong. But the galaxies are just the start. The telescope didn't just break the timeline, it found 7 distinct anomalies that suggest our universe is not what it seems. From the edge of space to the silence of alien life, we are going to walk through the 7 discoveries that are breaking physics right now. Okay, let's look at the first piece of evidence. In May of 2024, the telescope spotted something that shouldn't exist. This is an object called JD's, Z14 if the card. I know, terrible name, but focus on that Z14 part. That is the redshift number. It tells us that we are seeing this object as it was just 290 million years after the Big Bang. Now, why is that a problem? Because at that time, the universe was basically a newborn. It should have been a ghost town. Just hot gas, darkness, and silence. But JD's is not a ghost. It is a fully powered galaxy. It is bright, it is massive, and it is huge, hundreds of millions of times heavier than the sun. Think about the logic here. How do you build a skyscraper in 5 minutes? You can't. You need time to pour the concrete, you need time to weld the steel. But the universe somehow built a massive, complex structure in a blink of an eye. So we have to ask, is our timeline broken? Or did something impossible happen in the dark? Here is where the mystery gets even weirder, because the problem isn't just about the size of the galaxy, it's about what is inside it. You have to remember that to build a planet like Earth, or a complex biological machine like a person, you need heavy ingredients like carbon and oxygen. But the Big Bang didn't make those things. The Big Bang was a simple event that only created hydrogen and helium. That is it. To get the heavy stuff, you need a furnace. You have to cook those ingredients inside the cores of stars. A star has to form, burn for millions of years to crush hydrogen into new elements, and then it has to die and explode to scatter those ingredients out into the galaxy. It is a slow, generational process. You absolutely cannot cheat the chemistry. But when James Webb analyzed the light coming from JD's, do you know what it found? It found a chemical signature that was full of carbon and full of oxygen. This is the smoking gun. It means that by the time we see this galaxy, entire generations of stars had already lived their lives, died, and exploded to create that dust. How is that physically possible? If the universe is only 290 million years old at that point, where did all that time come from? It's like walking into a brand new house that was built yesterday, smelling the fresh paint, and then walking into the living room and finding a 100-year-old antique chair sitting there. The chair proves that someone was here long before the house was supposedly built. Who put it there? And more importantly, does the existence of that antique dust mean the house is actually billions of years older than we think? For 50 years, practically every astronomer on Earth agreed on one specific story about the past. They told us that after the Big Bang, there was a long quiet era called the Cosmic Dark Ages. The theory was that the universe was pitch black for 400 million years, until gravity slowly, painstakingly pulled the fog together to turn on the first lights. It was a neat, logical theory that made everyone feel safe, because it described a predictable, gradual evolution. Well, James Webb just took that theory and threw it in the trash. By finding these massive, bright galaxies so early, the telescope proved that the Dark Ages never happened. The lights were already on. The universe didn't wake up slowly like we thought. It woke up instantly. This is a nightmare for physics because our standard model assumes that gravity needs time to build structure. We assume that invisible dark matter builds the skeleton of the universe first, and then normal matter fills it in later. But the data shows normal matter grouping up into cities of light immediately, without waiting for the dark matter skeleton. So, what else are we wrong about? If we missed an entire era of cosmic history, if the Dark Ages were actually full of light and monsters, what other things are hiding in the timeline that we haven't found yet? So, how do we fix this broken timeline? Some scientists are rightfully panicking. They are realizing that you simply can't fit these massive galaxies into the current calendar. So, a physicist named Rajendra Gupta proposed a radical solution that sounds insane, but might be our only hope. He asked, what if the universe isn't 13 billion years old? What if it's 26 billion years old? He thinks we have been reading the clock wrong the whole time. He suggests that light gets tired as it travels across space, losing energy and making things look further away and faster than they actually are. If he is right, the universe is double the age we thought. That would give gravity plenty of time to build the monsters we are seeing, and it solves the construction problem perfectly. But here is the catch, and it's a big one. If we accept this new age, we have to break everything else. We have to throw away our understanding of dark energy. We have to rewrite every textbook on how the universe expands. It is a trade-off where we fix one error by creating 5 new ones. Are we ready to burn down physics just to save the timeline? Or does the answer lie in something even scarier? The idea that maybe the universe is infinite and it doesn't have a beginning at all? Okay, let's stop trying to patch the timeline for a second and look at the third option. This is the one that makes the hairs on the back of your neck stand up. There is a Nobel Prize winner named Roger Penrose who looks at this James Webb data, and he doesn't see a new universe at all. He thinks we are looking at a graveyard. He believes that the Big Bang wasn't the beginning of the story. He thinks it was just a reset button. Think about how a video game works. You play the level, you build your city, you fight the war. Then the game ends. The screen fades to black. The buildings are wiped away, but the code of the game is still there in the memory. Penrose argues that the universe does the exact same thing. It expands for trillions of years until everything burns out and fades into light. Then, when the emptiness is absolute, the geometry snaps back to zero and triggers a new Big Bang. It is a cycle that runs forever. Now, why does this matter for the James Webb data? Because if this is true, those impossible galaxies aren't glitches. They are leftovers. They are the debris from the previous game session that managed to survive the reset. This explains why they are so heavy and full of metal. They didn't start from scratch. They inherited the wreckage of the universe that died before we were born. We like to think we are writing on a fresh sheet of paper. But Penrose is saying we are writing on a page that has been erased 1 billion times, and the old ink is bleeding through. So ask yourself, are we the first ones to be here? Or are we just living in a recycling plant, building our bodies out of atoms that used to belong to a dead civilization? You are probably thinking, that sounds like a cool story, but show me the proof. You can't just claim the universe is infinite without backing it up. Well, Penrose says the proof is already there, staring us in the face. He calls them Hawking points, but you can think of them as scars. Here is the logic. We used to think black holes were eternal trash cans that never changed, but we know now that they actually leak. Over trillions of years, a supermassive black hole will slowly evaporate until it disappears in one final, massive burst of energy. Penrose argues that this burst is so powerful it leaves a mark on the fabric of reality itself. Imagine you throw a heavy rock into a perfectly still pond. The rock sinks, but the ripples keep moving across the water long after the rock is gone. Penrose says those ripples from the death of black holes in the last universe are still moving through our universe today. He points to specific hotspots in the sky, spots that James Webb is now studying, and says, "That is a ghost." He claims we are seeing the gravitational echo of a monster that died eons ago. If he's right, then the early universe wasn't smooth and new. It was bruised. It was full of shockwaves from the past. Does that make you feel infinite? Or does it make you feel like you're walking through a haunted house where the walls are screaming? Let's leave time behind for a moment and talk about space. Because if the timeline is a loop, the space we live in is a cage. When you look up at the night sky, you have this gut feeling that it goes on forever. You feel like if you had a fast enough ship, you could just fly in a straight line and keep finding new stars until the end of time. But physics says that feeling is a lie. The universe has a hard wall. We call it the particle horizon. Because light takes time to travel, we can only see a specific distance. It forms a perfect bubble around us. Anything outside that bubble is dead to us. We can't see it, we can't touch it, and we can't talk to it. But here is the claustrophobic part. The bubble is shrinking. Okay, technically the bubble is growing, but the universe is stretching apart faster than the bubble grows. The galaxies near the edge are moving away from us faster than the speed of light. That means they are falling off the edge of the world. Every second that I am talking to you, a galaxy crosses that horizon and vanishes from our reality forever. We aren't sailing on an open ocean. We are running on a treadmill that is speeding up. James Webb was built to look right at the edge of this treadmill. And what it is finding at the wall isn't empty space. It is finding evidence that our bubble might be crashing into something else. If we are locked in a room, the most important question is, who is banging on the other side of the door? If we are trapped in a bubble, what is outside of it? Standard science usually says we can never know, but there is a weird anomaly in the data that suggests something massive is lurking out there in the dark. Astronomers call it the dark flow, and it breaks the rules of gravity. Here is what happened. A team of scientists looked at hundreds of gigantic galaxy clusters. In a normal universe, these clusters should be drifting randomly, but they aren't. They are all rushing in the exact same direction. They are moving at 2 million miles per hour toward a specific patch of sky. It is like watching a river suddenly decide to flow uphill. There is not enough mass inside our bubble to pull them that fast. The math doesn't work. The only logical explanation is that something outside our visible universe is pulling them. Imagine you are in a windowless room, and suddenly all the steel furniture starts sliding across the floor toward the north wall. You can't see through the wall, but you know there must be a giant magnet on the other side. That is dark flow. It is the shadow of a titan we cannot see. James Webb is refining these measurements, and the pull looks real. So, what is big enough to drag 1 billion galaxies across the sky? Is it a megastructure? Is it a pile of matter left over from the Big Bang? Or is it another universe entirely that is getting too close for comfort? The idea of another universe hitting ours sounds like science fiction, right? But there is a physical mark on the sky that suggests the collision has already happened. It is called the cold spot. When we look at the heat map of the early universe, it should be the same temperature everywhere. Uniform, boring. But there is one massive region in the southern sky that is freezing cold. It is a giant deep freeze anomaly that is 1 billion light years wide. For years, scientists tried to say it was just a random error, a trick of the dust. But James Webb is showing us that the region is actually a super void, a massive hole in the Swiss cheese of the cosmos where almost nothing exists. But even a void shouldn't be this cold. One terrifying theory is that this spot is a bruise. The physicist Laura Mersini-Houghton argues that our universe is just one bubble in a giant foam of other bubbles. Sometimes they bump into each other. If our bubble smashed into another universe early in its history, That crash would have pushed matter away and left a cold, damaged scar. Think about two soap bubbles floating in a sink. When they touch, they flatten against each other. If she's right, the cold spot is the point of impact. It is where our reality slammed into a neighbor. This changes everything. It means we aren't safe in isolation. We are floating in a crowded bathtub, and we have already taken a hit. If we collided once, we can collide again. And the next time, the bubble might not just get a bruise, it might pop. We have established that the map of the universe is not what you think it is. You probably cherish the idea that our galaxy, the Milky Way, is just drifting peacefully through the void, like a raft on a calm ocean. You imagine we are sitting still in a quiet corner of space, but that is a lie. If you look at the data from the cosmic microwave background, it reveals that we are not drifting. We are rushing. Our entire galaxy, along with our neighbors in the local group, is moving at a speed of 630 kilometers per second. That is over 1.4 million miles per hour. We are moving faster than an explosion. Why? What could possibly be heavy enough to drag an entire galaxy that fast? For decades, astronomers thought we were simply falling toward a massive cluster of stars called the Great Attractor. It made sense. Gravity pulls. But when they did the math, the Great Attractor wasn't heavy enough to explain our speed. The numbers didn't add up. We were moving too fast. It wasn't until 2017 that we looked behind us and realized the terrifying truth. We aren't just being pulled, we are being pushed. Directly behind us sits a massive region of absolute nothingness, called the dipole repeller. It is a void so empty that it effectively has negative gravity. Because the regions in front of us have matter, and the region behind us has none, the vacuum is shoving us away. We are being sandwiched between a void that pushes and a supercluster that pulls. We are caught in a gravitational wind tunnel that spans hundreds of millions of light years. We are not steering this ship. We are debris caught in a current, rushing toward a collision we cannot see, driven by the emptiness itself. The fact that we are trapped in this violent flow changed the way we think about our neighbors. It forced us to abandon the naivety of the past. For 60 years, the human race relied on a strategy to find aliens that was, frankly, embarrassing. We sat by the radio. We pointed giant dishes at the stars and waited for a phone call. We assumed that if intelligent life existed, it would want to be found. We assumed they would be loud. But why would they be loud? Think about the logic of survival. If you are walking through a dark forest at night, do you scream at the top of your lungs to let everyone know you were there? Or do you stay quiet? We listened to the static for decades and heard zero, nothing, just the cold hiss of radiation. So with the James Webb Telescope, we stopped being polite, we stopped listening, and we started hunting. We realized that a paranoid civilization can turn off its radio. It can encrypt its Wi-Fi. It can hide its ships in the dark. But do you know what it cannot hide? It cannot hide its breath. Biology is a chemical fire. It burns resources and creates waste. Every living thing on Earth, from the bacteria in the soil to the cows in the field, changes the chemistry of the air. We breathe out carbon dioxide. Plants pump out oxygen. Industry pumps out smog. You can hide your math, but you cannot hide your atmosphere. If you are alive, you pollute your air. It is a fundamental law of existence. So we turn the telescope into a predator. We aren't asking them to talk to us anymore. We are sniffing the air of every planet within 40 light years, daring them to try and hide from us. So how do we actually catch them? How does a telescope see the air of a planet that is trillions of miles away? To understand this, I want you to imagine a simple shadow puppet show. Imagine a bright light shining on a wall. Now, imagine someone walks in front of that light. You see their shadow, but if that person is holding a glass of colored water, the light doesn't just get blocked, it gets filtered. The light passes through the water and changes color. This is exactly what happens when an exoplanet passes in front of its star. The star is the flashlight. The planet is the person. And the atmosphere is the glass of water. For a few hours, the starlight shines through the edge of the planet's atmosphere on its way to Earth. As that light travels through the air, the gases floating there steal specific parts of the beam. Oxygen steals red light. Methane steals blue light. Carbon dioxide steals another specific shade. When that light hits the mirrors of James Webb, it carries a barcode. By reading the missing colors, we can tell you exactly what is floating in the sky of a world you will never visit. We are not guessing anymore. We are getting the receipts. We can see water vapor. We can see ozone. But most importantly, we can scan for things that nature cannot produce. We can look for chlorofluorocarbons, the artificial gas we used in spray cans. Nature doesn't make that. Only factories do. If we see that gas, we know for a fact that there is a civilization down there. It removes the ambiguity. We are effectively looking through the bedroom windows of our neighbors to see if the lights are on. So, what is the scanner finding? Is it finding the smog of industry? Is it finding the chaotic breath of life? We are hunting for chaos. We are hunting for an atmosphere that looks unbalanced, like Earth's. Look at the air you are breathing right now. It is full of oxygen and methane at the same time. In a test tube, those two gases hate each other. They react. They burn. They turn into water and carbon dioxide. They should disappear instantly. The only reason they are both here is that life keeps pumping them out. Life creates a mess. Life keeps the chemistry agitated. But James Webb keeps finding order. It is seeing atmospheres that are perfectly stable. It is seeing worlds wrapped in heavy blankets of carbon dioxide or nitrogen where all the chemical reactions happened a billion years ago and stopped. They are calm. They are balanced. They are dead. This stability is a warning sign. It suggests that the natural state of the galaxy is a coma. We keep opening doors hoping to find a riot, and we keep finding empty, dusty libraries where nothing has moved for an aeon. It forces us to confront the uncomfortable possibility that the chaotic, unstable chemistry that keeps us alive is not a rule, but a freak accident. The silence isn't because our equipment is bad. The silence is because the universe naturally slides toward equilibrium, and life is just a temporary, violent struggle against that slide. We are looking for a pulse, but we are finding flat lines everywhere we look. This data leads us to the first major explanation for the silence, and it is the one that makes you feel the most isolated. It is called the rare Earth hypothesis. We have this optimistic arrogance that life is easy. We think that if you just add water and sunlight to a rock, biology appears automatically. We look at mold growing on a shower curtain and think, life finds a way. But the James Webb data is telling a different, much darker story. It looks like life might be a lottery ticket where you have to hit 1 million numbers in a row to win. Think about the engineering required to keep you alive right now. You needed a star that doesn't flare up and strip the atmosphere. Webb shows us that most red dwarfs are violent monsters. You needed a magnetic core to block radiation. Mars lost its core and died. You needed a massive moon to stabilize the planet's tilt. Without it, the seasons would be unsurvivable. You needed a Jupiter to suck up the asteroids. The telescope is showing us that most systems are broken. Their stars are violent. Their orbits are chaotic. Their planets are dry. The safe garden we live in might be a statistical impossibility that happened exactly once. We aren't finding neighbors because there are no neighbors. It's just us, holding a single candle in a hurricane, wondering why nobody else has a light. And if we are the only ones, the burden of survival becomes infinitely heavier. It means that if we snuff ourselves out, the entire universe goes back to being blind and dumb forever. We are not just inhabitants of the cosmos, we might be its only sensory organ. If we accept that the universe is empty, we have to face the darkest implication of that silence. It forces us to look at a concept called the Great Filter. You probably assume that the evolution of life is a ladder. You think that once a species learns to use tools, it naturally climbs up to radio, then to rockets, and finally to the stars. You think the hard part is behind us. You think the miracle was becoming intelligent in the first place. But the silence of the James Webb data suggests that you are wrong. It suggests that the ladder is broken. If intelligence was enough to conquer the galaxy, the sky would be full of ships. The fact that it is empty implies that there is a wall somewhere in the timeline, a barrier that stops civilizations from getting older. The terrifying question is, where is the wall? There are only two options. Option A is that the wall is behind us. Maybe the jump from single-celled slime to complex animals is incredibly rare. If that is true, we are the lottery winners. We are safe. But option B is the nightmare. Option B says the wall is in front of us. It implies that evolving intelligence is easy, but surviving intelligence is impossible. It suggests that every single civilization that discovers technology eventually destroys itself. They build a gun, they point it at their own head, and they pull the trigger. If this is true, we aren't looking at an empty universe because nobody lives there. We are looking at a graveyard where everyone died young. And we are currently sprinting toward the exact same wall that killed them. Let's look at why this wall might exist. We cherish the belief that being smart makes us safer. We think our big brains are survival tools. But if you look at the timeline of humanity, intelligence looks less like a tool and more like a lethal mutation. Think about the speed of our own destruction. We have existed as a species for 200,000 years. For almost all of that time, we were harmless. But in the last 80 years, a microscopic fraction of our history, we figured out how to split the atom. Then, we figured out how to edit DNA. Then, we figured out how to alter the climate of the entire planet. We are like a toddler who just found a loaded handgun in the toy box. The universe might be silent because high technology is a suicide pact. It is possible that as soon as a species creates the power to destroy itself, it inevitably uses it. James Webb might be finding empty planets not because life is rare, but because L, the length of time a civilization lasts, is terrifyingly short. If the average lifespan of a technological society is only 300 years, then we are just a flash in the pan. We ignite, we burn bright for a second, and then we burn out. The silence you see in the sky is the statistical result of 1 billion civilizations flashing into existence and then evaporating before they could ever say hello. We are scanning for neighbors, but we are likely just scanning for the radioactive ash they left behind. But let's say we survive. Let's say we don't blow ourselves up. Surely then we are safe. Surely the universe itself is a solid stage where we can act out our future. We want to believe that the laws of physics are rock solid. We want to believe that gravity, light, and time are constants that we can trust. But James Webb is showing us that the stage itself might be rotten. There is a crisis happening in cosmology right now called the Hubble Tension. It sounds technical, but the implication is visceral. We have two ways to measure how fast the universe is expanding. We can look at the beginning of time, the cosmic microwave background, and predict how fast we should be growing. Or we can look at the nearby universe, the stars and galaxies around us, and measure how fast they are actually moving. Logic dictates that these two numbers must match. If you measure your height with a ruler today, and then you calculate your height based on how much you grew since you were a baby, you should get the same number. But the numbers do not match. The early universe predicts one speed. The James Webb data shows a different, faster speed. The discrepancy is impossible to ignore. It means that something is fundamentally broken in our understanding of reality. It is like looking in a mirror and seeing your reflection move a split second after you move. It proves that the system is glitching. The fabric of space is stretching faster than the laws of physics say it should. Either we are missing a massive piece of the puzzle, or the vacuum of space itself is changing its properties as it ages. The ground beneath your feet is not stable, it is stretching, and it is tearing apart the rules that hold you together. If the laws of physics are changing, we have to ask, is the universe stable? We assume that empty space is the bottom of reality. We assume that a vacuum is the lowest possible energy state, a solid floor that cannot go any lower. but quantum mechanics suggests that we might be standing on a trapdoor. This is the concept of false vacuum decay. Imagine you are standing on a frozen lake. The ice feels solid. You can walk on it. You can build a house on it. But underneath the ice, there is deep water. You are not at the bottom. You are just on a metastable layer. The James Webb data on the mass of the top quark suggests that our universe might be existing in this false state. The Higgs field, which gives everything mass, might not be at its true 0 point. It might be stuck on a ledge. If this is true, it means the universe is a ticking time bomb. At any moment, in any random point in space, the vacuum could tunnel through the ice. A bubble of true vacuum would form. Inside that bubble, the laws of physics would be completely different. Atoms would not hold together. Chemistry would be impossible. And here is the horror. This bubble expands at the speed of light. You would never see it coming. 1 second, you are here, and the next second, the fundamental rules that allow your atoms to exist are rewritten. We are building our lives and our history on a sheet of ice that is slowly melting, hoping that we don't fall through before the sun burns out. If the vacuum is unstable and the expansion is breaking, what is the universe actually made of? We feel like we live in a 3-dimensional world. You can move up, down, left, right, forward and back. Objects feel solid. You feel solid. But James Webb is looking at black holes, and the data it sees there suggests that solid is just a user interface. When a black hole eats information, that information doesn't disappear inside the volume of the hole. It gets plastered onto the surface, the event horizon. It implies that the amount of stuff a region of space can hold depends on its surface area, not its volume. This leads to the holographic principle. It suggests that the 3D reality you are walking through is actually a projection. Just like a hologram on a credit card looks 3D but is actually flat, our entire universe might be 2D information painted on a distant cosmological horizon. You are not a body moving through space. You are data being processed on a surface. The pixels of this reality are called the Planck length, and they are incredibly small, but they are there. If this is true, then we are not physical beings. We are calculations. We are code running on a quantum computer that sits at the edge of time. And what happens to code when the system crashes? What happens when the simulation reaches its memory limit? The anomalies James Webb is seeing, the impossible galaxies, the tension in the expansion, might not be physical mysteries. They might be artifacts of compression. We might be seeing the resolution of the universe starting to blur because the machine is running out of RAM. You think you're looking at the stars, but you might just be looking at the pixels of a screen that is about to turn off. Here are bits 21 through 25. I have strictly mimicked the style of the reference text. Direct address to you, deconstructing your intuitions, using concrete thought experiments, and maintaining high volume by exploring the terrifying implications of the logic. We assume that life is the point of the universe. We look at the Earth, with its green forests and blue oceans, and we think that this is the natural end state of any wet rock. You feel that if you just add water and sunlight to a planet, biology will inevitably crawl out of the mud. It feels logical. It feels like a law of nature, but it is not true. Chemistry does not want to be alive. Chemistry wants to be dead. To understand why you are a statistical impossibility, you have to look at the machinery inside your own cells right now. You are powered by a molecule called ATP. It is a complex, twisted little machine that stores energy. Without it, you die in seconds. But to make ATP, you need an enzyme called ATP synthase. And to make ATP synthase, you need DNA. And to read the DNA, you need ATP. Do you see the trap? It is a closed loop. You need the machine to build the fuel, but you need the fuel to run the machine that builds it. So, how did the first cell start? It had to assemble itself by pure accident. Imagine you take a box full of watch parts, gears, springs, screws, and you shake it. How long do you have to shake that box before the parts accidentally fall together into a perfectly working Rolex that is already wound up and ticking? You could shake that box for 1 trillion years, and you would just get a pile of metal dust. You would get entropy. But the universe shook the box of chemistry on Earth, and somehow, it didn't just build a watch. It built a watch that can build other watches. James Webb is showing us that this accident didn't happen anywhere else. It scans planet after planet, looking for that spark, and it finds nothing but the cold logic of dead chemistry. It finds carbon dioxide and nitrogen sitting there in perfect, boring equilibrium. This suggests that you are not the rule. You are the exception. You are the result of a freak roll of the dice that happened once in a burning house, and now you are sitting alone in the ashes, wondering why no one else is playing the game. But let's assume the optimists are right. Let's assume that life is easy, and the galaxy is teeming with civilizations. If the room is crowded, why is it so quiet? You might think that space is just too big, or that our radios are too weak. You assume that aliens are like us, curious, loud, and eager to make friends. You imagine a Star Trek universe where species meet and trade and learn. But have you ever stopped to ask yourself if being loud is actually a smart move? Think about the history of your own planet. When a less advanced civilization meets a more advanced civilization, what happens? Does it result in a wonderful exchange of culture? Or does it result in the immediate destruction of the weaker party? The silence of the universe might not be a technical problem. It might be a survival strategy. If you're walking through a dark forest at night, and you are unarmed, and you hear a twig snap, do you scream, "Hello?" Do you turn on a flashlight and wave it around? No. You freeze. You hold your breath. You do everything in your power to vanish. Because you know that in the dark, the only things making noise are the predators. The James Webb Telescope is scanning the sky, and it sees a galaxy that is quiet. Paranoidly quiet. This implies that the other civilizations know something we don't. They know that the universe is not a playground. They know it is a hunting ground. And the reason we haven't heard from them is that they are hiding from the exact same thing that we should be hiding from. They are terrified. And we are the only idiots in the forest walking around with a megaphone. To understand the mind of the hunter, we don't need to look at aliens. We just need to look at game theory. There is a concept called the chain of suspicion that explains why peace is mathematically impossible in a large universe. Imagine you are a soldier sitting in a dark trench. You know there is another soldier in a trench opposite you. You can't see him. You don't know if he is good or evil. You don't know if he is scared or aggressive. You only know two things. First, you want to survive. Second, he has a gun. If you try to talk to him, you reveal your position and he might shoot you. If you wait, he might develop a bigger gun and shoot you later. You can't trust him, because even if he says he is peaceful, he might be lying. And he can't trust you, because he thinks you might be lying. The distance between you prevents any real understanding. The logic of the situation forces your hand. The only way to guarantee 100% that he will not kill you is to kill him first. This is the state of the galaxy. It is a dark forest, where every civilization is a hunter armed with a gun. They are separated by light years of distance, which creates a chain of suspicion that cannot be broken. If James Webb finds a planet with an advanced industrial atmosphere, we won't know if they are artists or conquerors. We will only know they have the power to hurt us. And they will look at Earth, see our oxygen and our satellites, and they will do the math. They will realize that it is safer to wipe us out now, while we are still stuck on one planet, than to wait for us to become a threat. The silence is not empty. The silence is the tension of 1 billion fingers hovering over 1 billion triggers. You might be thinking, okay, but space is huge. Even if they want to kill us, it would take them thousands of years to get here. You are operating under the comfortable assumption that war requires ships. You think of an invasion as a fleet of saucers landing on the White House lawn. But that is Hollywood physics. Real physics is much faster and much harder to see. If a civilization wants to eliminate us, they don't need to invade. They just need to sterilize. And they don't need a Death Star to do it. They just need a rock. If you take an asteroid the size of a school bus and accelerate it to 90% of the speed of light, it carries the kinetic energy of a nuclear arsenal. It doesn't need a warhead. The speed is the weapon. Now, think about the lag we talked about earlier. We see the universe as it was, not as it is. If a hostile civilization located 1,000 light years away decided to fire that rock at us today, we wouldn't see the launch. The missile moves almost as fast as the light that carries the image of the missile. This means we would never see it coming. The weapon would trail just behind its own image. One moment, you are looking at a peaceful star in the night sky. The next moment, the atmosphere catches fire, the oceans boil, and the crust of the Earth is peeled off like the skin of an orange. There is no warning. There is no negotiation. There is just an instant, violent deletion. James Webb might be looking at a star system right now that pulled the trigger 500 years ago, and the bullet is already halfway here. We are sitting in a room with a sniper, assuming we are safe because we haven't heard the shot yet. This brings us to the most terrifying realization about our place in the dark forest. If the universe is a place where survival depends on silence, then humanity has made a fatal mistake. We haven't just been noisy, we have been screaming. For the last 100 years, we have been blasting radio waves, television signals, and radar pulses into the void. We sent the Voyager probe with a map to our house, etched in gold. We sent high-power messages from the Arecibo dish, specifically trying to get someone's attention. We are like a baby, crying in a forest full of wolves. We assumed that if someone heard us, they would come to help. We projected our own morality onto the cosmos. But if the dark forest theory is true, we have effectively painted a giant target on our own backs. The signals from the I Love Lucy broadcast in the 1950s have now washed over thousands of star systems. If anyone is out there listening, they know where we are. They know how primitive we are. And they know exactly how much water and biological resource is sitting on this rock. James Webb is now looking for technosignatures, heat from other civilizations. But we have to consider the possibility that the reason we don't find them is that everyone else learned the lesson a long time ago. They are quiet because the loud ones get eaten, and by the time we realize that we should have kept our mouths shut, it will be too late to take the signal back. The message is already out there, traveling at the speed of light, announcing to the galaxy that dinner is served. You might be asking a very logical question right now. If the universe is a dark forest, and if we have been screaming our location for 100 years, why are we still alive? Why haven't we been wiped out yet? You might take our continued survival as proof that the galaxy is safe, but that is a dangerous mistake. You are confusing safety with insignificance. Think about how you treat an anthill. If you're walking down the street and you see an anthill, do you stop to destroy it? Probably not. It isn't worth your time. It isn't worth the energy. You ignore it because it is not a threat to you. But what happens if those ants suddenly figure out how to build a nuclear bomb? What happens if they start expanding onto your driveway? Then you destroy them. You pour gasoline down the hole and you light a match. This is the position humanity is in right now. For thousands of years, we were just ants moving dirt. We were invisible to the big players in the galaxy. But in the last century, we learned how to split the atom. We learned how to leave our planet. We crossed the threshold from biology to technology. We just became visible. The James Webb Telescope is looking for technosignatures from them, but they are likely looking for heat signatures from us. We are currently in the grace period between becoming a nuisance and becoming a threat. The silence isn't a sign of peace, it is the pause before the exterminator arrives. We are building a highway right next to a sleeping predator, assuming that because it hasn't woken up yet, it never will. Let's leave the biological threats for a moment and look at the stage itself. Because even if we hide from the aliens, and even if we survive our own weapons, we still have to live in this universe. We assume that the physical world is solid. We trust that the laws of physics are constant, unchangeable rules that hold reality together like steel beams in a skyscraper. But James Webb is showing us that the beams are bending. There is a crisis happening in cosmology right now, and it is not a theory. It is a measurement. We have two ways to calculate how fast the universe is expanding. Method 1 is to look at the beginning of time, the cosmic microwave background, and project forward. It predicts a specific speed. Method 2 is to look at the local universe, the stars and galaxies around us right now, and measure them directly. Logic dictates that these two numbers must match. If you measure your height with a tape measure today, and then calculate your height based on how much you grew since you were a baby, you should get the same number. If you don't, either you are crazy, or the ruler is broken. Well, the numbers do not match. The early universe predicts one speed 67 kilometers per second per megaparsec. The local universe shows a much faster speed, 73 kilometers per second per megaparsec. This gap is called the Hubble Tension. For years, scientists hoped it was just a mistake. They hoped their telescopes were blurry. But James Webb is perfect. It looked at the Cepheid variable stars, the mile markers of the universe, and it confirmed the discrepancy. The ruler is definitely broken. This implies that the universe is expanding faster than the laws of physics can explain. It is like looking in a mirror and seeing your reflection move a split second before you do. It proves that the system is glitching. Something fundamental in the machinery of space-time is broken, and we don't know how to fix it. What does this tension actually mean for you? It sounds like an abstract math problem, but the implications are physical and violent. It suggests that our model of the universe, the lambda CDM model that we print in every textbook, is wrong. It means we are missing a massive piece of the puzzle. Some physicists think this extra speed comes from early dark energy, a mysterious force that kicked the universe in the shin right after the Big Bang. Others think that gravity itself creates leaks in reality. But the scary part is what this says about the stability of the future. If we can't predict the expansion rate, we can't predict the fate of the universe. We used to think the universe would expand forever, slowly cooling down. But if the expansion is accelerating uncontrollably, we might be heading for a big rip. Imagine painting a picture on a rubber balloon. As you inflate the balloon, the picture stretches. That is normal expansion. But if you inflate it too fast, the rubber fails. The atoms of the rubber can't hold onto each other. If the big rip scenario is true, the expansion of space will eventually overcome gravity. First, it will tear galaxies apart. Then, it will tear solar systems apart. The Earth will be ripped away from the Sun. Then, in the final fraction of a second, the expansion will overcome the electromagnetic force. Your body will be ripped apart. The atoms themselves will be shredded. James Webb's data on the acceleration of the universe suggests that the gas pedal is being pressed harder than we thought. We aren't just driving fast. We are driving a car that is vibrating apart because the engine is too powerful for the chassis. If the expansion is breaking the large-scale structure, what is happening to the small-scale structure? This brings us to the most terrifying concept in all of quantum mechanics. It is the idea that empty space is not actually empty. We assume that a vacuum is the floor of reality. It is the lowest possible energy state. When you take away all the air and all the matter, you hit the bottom. You are standing on solid ground. But the math suggests we might be standing on a trapdoor. This is called false vacuum decay. Imagine you are hiking on a mountain. You find a nice flat valley, and you set up your tent. You think you're at the bottom of the mountain, but you're actually just on a ledge. There is a sheer drop of another 1,000 feet right next to you, hidden by the fog. The Higgs field, the energy field that gives mass to every atom in your body, might be stuck on that ledge. It is metastable. It looks stable, but it isn't at the true bottom. The James Webb Telescope is indirectly studying the mass of the top quark, and the numbers are uncomfortably close to the edge of stability. If the Higgs field ever slips off that ledge, it will crash down to the true vacuum. This would release a catastrophic amount of energy. But the real horror is that it would rewrite the laws of physics. In the true vacuum, the constants of nature change. Chemistry becomes impossible. Atoms simply fall apart. Your body is held together by the current value of the Higgs field. If that value changes, you don't just die. You cease to exist as matter. You dissolve into a soup of quantum noise. Here is the worst part about vacuum decay. You cannot see it coming, you cannot prepare for it, and you cannot run from it. If the vacuum collapses, it will start at a single random point in space. It could happen a billion light years away, or it could happen inside your coffee cup. Once it triggers, a bubble of true vacuum forms. This bubble expands outward at the speed of light. Think about what that means. We see the universe through light. Information travels at the speed of light. If a disaster is traveling at the speed of light, it arrives at the exact same moment as the warning. You would never see the bubble. One moment, you are sitting there, alive, holding your phone. The next moment, the wall of the bubble hits you. Your neurons dissolve before they can fire the electrical signal to your brain to say, "I am in pain." You wouldn't feel it. You wouldn't hear it. The universe would simply switch off. For all we know, a bubble of death was triggered in the Andromeda Galaxy 2 million years ago. It is rushing toward us right now, tearing apart stars and erasing physics as it comes. It is halfway here, and we will continue to pay our taxes and worry about the weather until the exact millisecond it arrives. We are building our entire history on a sheet of ice that might have already cracked, but the sound of the crack hasn't reached us yet. If the vacuum is unstable and the stage is rotting, we have to ask what the stage is actually made of. You have a very strong intuition that the world is smooth. When you move your hand through the air, it feels like a continuous, fluid motion. If you zoom in on a line drawn on a piece of paper, you assume you can keep zooming in forever. You think reality is analog. But James Webb is looking at the extreme physics of the early universe, and the data suggests that your intuition is a lie. Reality is not smooth. It is jagged. There is a concept in physics called the Planck length. It is the smallest possible unit of measurement. It is the resolution limit of the universe. Imagine you are looking at a high-definition photo on your computer screen. From a distance, the curves look perfect. The colors blend smoothly. But if you zoom in enough, if you get your face right up against the glass, the illusion breaks. You see the squares, you see the pixels. You realize that the smooth image is actually a grid of distinct, blocky data points. Quantum mechanics says the universe works the exact same way. You cannot move half a Planck length. You snap from one coordinate to the next. You're not moving smoothly through space. You are teleporting across a grid at an incredible frame rate. This implies that the universe is not a physical place. It is a calculated place. It has a resolution. And if it has a resolution, that means it uses memory. The anomalies James Webb is seeing, the galaxies that grew too fast, the expansion that doesn't match, might not be mysteries of nature. They might be rendering errors because the system is running out of RAM. So if the universe is made of pixels, where is the hard drive? Where is the data actually stored? To find the answer, we have to look at the only object in the universe that breaks all the rules, the black hole. James Webb is staring into the hearts of galaxies to study their supermassive black holes, and what it finds there destroys the concept of 3D space. Here is the paradox. A black hole eats matter. It eats stars, gas, and light. All that stuff contains information. In physics, information is the description of how particles are arranged. When a black hole swallows a star, you would assume that the information about that star goes inside the hole, filling up the volume. But the math says no. Stephen Hawking and Jacob Bekenstein realized something impossible. The amount of information a black hole can hold does not depend on its volume. It depends on its surface area. It depends on the size of the event horizon, the shell around the hole. Think about what that means. If you throw a library into a black hole, The books don't disappear into the center. The information in those books gets plastered onto the surface, like stickers on a suitcase. The inside of the whole is an illusion. The data is entirely on the outside. This suggests that the third dimension, depth, is not a fundamental feature of reality. It is a trick. And since the universe is effectively a giant gravitational system, this rule applies to you too. This leads us to the most claustrophobic theory in modern physics, the holographic principle. If the information of a black hole lives on its 2D surface, then the information of our universe might live on the cosmic horizon, the edge of the observable bubble we talked about earlier. Everything you see, everything you touch, and everything you feel might be a projection. Look at a hologram on a credit card. It looks 3D. If you tilt it, you can see the sides of the bird or the logo. It has depth. But if you run your finger over it, it is flat. The depth is a rendering trick, caused by the way light bounces off the 2D surface. Physics suggests you are the bird on the credit card. The real you is a smear of data scrambled on the edge of the universe, billions of light years away. The version of you sitting in that chair is just a ghost, a holographic projection of that distant data. You feel solid because the projection is high quality. You feel pain because the code says you should. But you have no volume. You are a flat creature hallucinating that you have depth. And if the screen flickers, if the vacuum decays or the expansion rips, the projection simply turns off. You don't die, you just stop being rendered. If we are a projection, and if we are made of pixels, then we have to use the word that makes everyone uncomfortable: simulation. We have to ask if the universe is a computer. Look at the impossible galaxies found by James Webb again, JADES GS Z140. It appeared too early. It is too big. It defies the laws of gravity. In a physical universe, this is a crisis. But in a simulation, this is a recognizable bug. Think about how a video game loads a level. Sometimes, to save processing power, the game uses procedural generation. It creates the world as you walk into it. Sometimes, the code glitches, and it spawns a high-level boss in the starting area. The massive galaxies at the dawn of time look exactly like a procedural generation error. They look like assets that were loaded in the wrong order. The Hubble Tension, the fact that the universe expands at different speeds depending on where you look, looks like a processing lag. It looks like the server is struggling to keep the different parts of the map synchronized. We are finding evidence that the laws of physics are not absolute. They are just the operating system's settings. And the scary part about code is that code can be rewritten. Code can be paused. And code can be deleted. If we are living in a simulation, we are not the players. We are the NPCs. We are the background characters wondering why the sky is changing color, unaware that someone is about to reset the console. This brings us to the ultimate consequence of being information. Whether we are a hologram, a simulation, or just a biological machine, we are subject to the harshest law in existence, entropy. And in the language of information theory, entropy isn't just disorder, it is deletion. Information is fragile. To keep a memory, you need energy. To keep a body organized, you need food. To keep a civilization running, you need power. You have to constantly fight against the universe's desire to scramble you. But the second law of thermodynamics guarantees that you will lose. Every time you access a memory, it degrades slightly. Every time a cell divides, the DNA gets a tiny bit corrupted. We call this aging, but it is actually data rot. We are files that are slowly becoming unreadable. The James Webb Telescope shows us the end game of this process. It looks at old, dead galaxies where star formation has stopped. It sees the heat death in action. The universe is slowly shuffling the deck of cards until all the patterns are gone. When you die, the pattern that is your consciousness doesn't go somewhere else. It dissolves. The magnetic bonds in your brain loosen, and the data is overwritten by noise. If we are just code, then death is the equivalent of formatting the hard drive. There is no backup. The terror of the holographic universe is that once the projection stops, the information is scrambled back into the random static of the horizon. You aren't just mortal, you are deletable. We have established that the universe might be made of pixels, but where is the screen? To find the answer, we have to look at the only object in the universe that breaks every rule of physics: the black hole. James Webb is peering into the centers of galaxies to study these monsters, and what it finds there destroys the concept of 3D space entirely. Here is the paradox that keeps physicists awake at night. A black hole eats matter. It eats stars, gas, and light. In physics, all that stuff is just information. It is a description of particles. When a black hole swallows a star, you would instinctively assume that the information about that star goes inside the hole, filling up the volume like water filling a bucket. You assume that the more a black hole eats, the fuller the inside gets. But the math says no. Stephen Hawking and Jacob Bekenstein discovered something impossible. The amount of information a black hole can hold does not depend on its volume. It depends on its surface area. It depends entirely on the size of the event horizon, the shell around the hole. Think about the terrifying implication of that. If you throw a library into a black hole, the books don't disappear into the center. The information in those books gets plastered onto the surface, like stickers on a travel trunk. The inside of the hole is a lie. The volume doesn't exist. All the data is stored on the 2D shell. This suggests that the third dimension, depth, is not a fundamental feature of reality. It is a rendering trick. And since the universe is effectively just a giant gravitational system, this rule applies to you too. You feel like you have insides. You feel like you have a heart, a brain, and a stomach that exist in a 3D space. But the laws of the holographic universe say that you are actually a flat smear of data painted on a distant surface, and your brain is just hallucinating the feeling of depth. This leads us to the holographic principle, which is the most claustrophobic theory in modern science. If the information of a black hole lives on its 2D surface, then the information of our universe lives on the cosmic horizon, the edge of that observable bubble we talked about earlier. Everything you see, everything you touch, and every person you love might be a projection. Look at a hologram on a credit card or a banknote. When you look at it, it looks 3D. If you tilt it, you can see the sides of the bird or the building. It has depth, it has shape. But if you run your finger over it, it is perfectly flat. The depth is an illusion caused by the way light bounces off the 2D surface. Physics suggests you are the bird on the credit card. The real you is a string of ones and zeros scrambled on the edge of the universe, billions of light years away. The version of you sitting in that chair, breathing air, is just a ghost, a holographic projection of that distant data. You feel solid because the projection is high quality. You feel pain because the code says you should. But you have no volume. You are a flat creature dreaming that you are solid. And this explains why James Webb sees glitches in the deep universe. If we are a projection, then the resolution depends on the distance from the source. As we look further back, toward the horizon where the data is stored, things should start to get blurry. The impossible galaxies, the tension in the expansion rate. These aren't mysteries of nature. They are artifacts of compression. We are seeing the pixels of the screen because we are looking too closely at the lens. If we are a projection, and if we are made of pixels, then we have to use the word that makes everyone uncomfortable: simulation. We have to ask if the universe is a computer. Look at the impossible galaxies found by James Webb again. Jades, Z14. It appeared too early. It is too big. It defies the laws of gravity. In a physical, organic universe, this is a crisis. But in a simulation, this is a recognizable bug. Think about how a video game loads a massive open world. To save processing power, the game uses procedural generation. It creates the trees and the buildings only when you walk near them. It renders the world on the fly. But sometimes, the code lags. Sometimes the math makes a mistake, and it spawns a high-level boss in the starting area, Or it loads a building that floats in the sky. The massive galaxies at the dawn of time look exactly like a procedural generation error. They look like high complexity assets that were loaded in the wrong order because the server was lagging. The Hubble Tension, the fact that the universe expands at different speeds depending on where you look, looks like a processing disparity. It looks like the system is struggling to keep the different parts of the map synchronized. We are finding evidence that the laws of physics are not absolute rules. They are just the operating system settings. The speed of light is the refresh rate. Gravity is the collision detection engine. And the scary part about code is that code can be rewritten. Code can be paused. And code can be deleted. If we are living in a simulation, we are not the players. We are the NPCs. We are the background characters walking in circles, wondering why the sky is changing color, completely unaware that someone is holding the power cord and they are about to pull it. This brings us to the ultimate consequence of being information. Whether we are a hologram, a simulation, or just a biological machine, we are subject to the harshest law in existence: entropy. And in the language of information theory, entropy isn't just disorder, it is deletion. Information is fragile. To keep a memory, you need energy. To keep a body organized, you need food. To keep a civilization running, you need power. You have to constantly fight against the universe's desire to scramble you. But the second law of thermodynamics guarantees that you will lose. Every time you access a memory, it degrades slightly. Every time a cell divides, the DNA gets a tiny bit corrupted. We call this aging, but it is actually data rot. We are files that are slowly becoming unreadable. The James Webb Telescope shows us the end game of this process. It looks at old, dead galaxies where star formation has stopped. It sees the heat death in action. The universe is slowly shuffling the deck of cards until all the patterns are gone. When you die, the pattern that is your consciousness doesn't go somewhere else. It dissolves. The magnetic bonds in your brain loosen, and the data is overwritten by thermal noise. If we are just code, then death is the equivalent of formatting the hard drive. There is no backup. The terror of the holographic universe is that once the projection stops, the information is scrambled back into the random static of the horizon. You aren't just mortal, you are deletable. And once the file is gone, the universe forgets you were ever there. But wait, there is one loophole in the logic of deletion. It is the concept of infinity. If the universe is a closed box, a finite amount of space with a finite number of atoms, and if time is infinite, then something terrifying happens to the math. It is called the Poincaré recurrence theorem. Imagine you have a deck of cards. You shuffle it. The order of the cards changes. You shuffle it again. It changes again. If you do this 1,000 times, you will see 1,000 different combinations. But the number of cards is limited. There are only 52. Therefore, the number of possible combinations is huge, but it is finite. If you keep shuffling that deck forever, for billions and trillions of years, eventually, you must repeat a sequence. You will inevitably shuffle the exact same order of cards that you held in your hand yesterday. The universe is just a very big deck of cards. The atoms in your body are the cards. The laws of physics are the shuffle. Right now, your atoms are arranged in a specific pattern that makes you you. Eventually you will die, and those atoms will be scattered. The deck will be shuffled. But if time goes on forever, the shuffling never stops. This means that eventually, it might take a number of years so big that it would fill a library with zeros. The atoms must come back together. They must reassemble into the exact same pattern they are in right now. You will be born again. You will grow up again. You will sit in this chair and watch this video again. You won't remember the last time, because your memory is part of the pattern that got reset. This isn't reincarnation. This is mathematical necessity. If the universe doesn't end, you don't end. You are trapped in a loop of existence that repeats every single mistake, every single pain, and every single joy, forever. You might be thinking, okay, so the atoms come back together in 1 trillion years. But that won't be me. That will just be a copy. I will be dead and gone. You are clinging to the idea that you have a soul. You think there is a magical ghost inside the machine that makes you unique, something that leaves the body when the biological clock stops. But modern physics and neuroscience have some very bad news for you. There is no ghost. You are your atoms. Your personality, your memories, your fear of spiders, the specific way you love your mother, all of it is physically encoded in the neural connections of your brain. You are a pattern of electricity running through meat. If I built an exact atom-for-atom replica of you right now, that replica wouldn't just look like you. It would be you. It would remember eating your breakfast. It would feel your anxiety. So, if the universe shuffles the deck and accidentally deals the you card again, it is not a twin. It is you. Think about the teleporter paradox. If you step into a Star Trek transporter, it scans you, destroys your body, and rebuilds an exact copy on the planet's surface. Is that copy you? Or did you die, and a new person took your place? In a material universe, the continuity of the pattern is the only thing that matters. So when the eternal shuffle rebuilds your brain in the next cycle of time, your consciousness snaps back on. You open your eyes, you take a breath. You have no memory of the 1 trillion years of darkness that just passed. As far as you are concerned, you just blinked. You are trapped in a machine that refuses to let you delete yourself. The universe is a copy machine that never runs out of paper, and you are the document on the glass. This brings us to the heaviest psychological weight you will ever have to carry. It is the realization that if the loop is real, then change is an illusion. We like to think we learn from our mistakes. We think life is a journey where we grow and get better. But in a recurrence loop, you don't learn. You repeat. The philosopher Friedrich Nietzsche called this the heaviest burden. Imagine a demon creeps into your bedroom tonight and whispers, "This life, as you live it now and have lived it, you will have to live once more and innumerable times more, and there will be nothing new in it." Think about what that actually means. It means every time you stubbed your toe, you will stub it again. Every time you had your heart broken, it will break again with the exact same sharpness. The boredom of waiting in traffic, the physical pain of a toothache, the grief of losing a loved one. You are condemned to repeat it forever. You're not living a life. You're acting out a script that was written eons ago, and you cannot change a single line. You will make the same bad decisions. You will say the same hurtful words to your partner in the heat of an argument, and you will feel the same regret over and over again for eternity. You are trapped on a roller coaster that never stops and never changes its track. The universe isn't a story moving toward a happy ending. It is a broken record skipping on the same groove of vinyl, screaming the same lyric into the void forever. If the idea of repeating your life sounds exhausting, mathematics has one final twist that turns exhaustion into pure nightmare fuel. We have assumed that the recurrence will be a perfect copy of your current life. We assume the universe will rebuild the whole world. But statistical mechanics suggests something else. It suggests that the house always wins, and the house likes chaos. In a chaotic universe that is randomly shuffling atoms, order is rare. A whole universe is a lot of order. A single brain is a lot less order. It is statistically much easier for the universe to accidentally assemble just your brain floating in the void than it is to assemble your brain and the Earth and the stars. This is the Boltzmann brain paradox. The math says that for every one real person living in a real timeline, there should be trillions of fluctuation brains that just pop into existence for a second. These brains would have false memories. They would hallucinate a past that never happened. They would think, I am sitting here watching a video about space, and then they would dissolve back into the chaos. If you believe in probability, you have to admit that it is overwhelmingly likely that you are one of these hallucinations. You are not a person with a history. You are a momentary glitch in the static. The universe didn't build a world for you, it just built a dream of a world, and in a microsecond, the dream will end. The silence of the universe might be because the other versions of you are screaming, and you are just the lucky one who happened to be hallucinating a quiet room for a brief moment. So, why do we feel? If we are just atoms, if we are just a shuffle of the deck, why does it hurt? Why do we care about the dark? We tend to think of consciousness as a gift. We think it is the crown jewel of evolution. But in the context of the James Webb data, consciousness looks more like a curse. The universe is mostly dead rocks, burning gas and freezing vacuums. Those things don't suffer. A star doesn't care if it explodes. A black hole doesn't feel lonely. We are the anomaly. We are the only part of the machine that knows it is trapped. Evolution gave us a brain designed to survive on the African savanna. It gave us anxiety to avoid lions. It gave us loneliness to keep us in the tribe. But then, by a freak accident, that brain got smart enough to build telescopes. We took a tool designed for hunting gazelles, and we pointed it at the abyss. This caused a mismatch. We have emotions that require meaning, but we live in a universe that is mathematically designed to destroy meaning. We are searching for a narrative in a system that only has mechanics. The terror you feel when you look at the dark forest or the false vacuum is the friction between your biology and your reality. You are a biological machine that has realized it is inside a meat grinder. The universe isn't cruel, it is indifferent. But to a creature that feels pain, indifference is worse than cruelty. We are the universe's way of crying, and the universe isn't listening. We have reached the absolute bottom of the trap. We have peeled back every layer of the onion, and every layer made us cry. Let's look at the full picture of the cage we have built tonight. Biologically, we found that we are trapped in a lag, 80 milliseconds behind reality, creating a simulation of the now just to catch a baseball. Physically, we are imprisoned by the speed of light, isolated in our own private time bubbles, unable to ever truly touch the present moment of another human being. Thermodynamically, we are being dragged toward a heat death, where our bodies and our achievements will dissolve into cold dust. And logically, we are stuck in an infinite loop of eternal return, doomed to repeat our mistakes forever, without memory or hope of escape. It seems that the universe is a closed circle. It is the Ouroboros, the snake eating its own tail. No matter where we turn, outward to the stars, inward to our atoms, or forward to the future, we hit a wall. The universe appears to be a hostile, chaotic machine that is actively trying to erase organized structures like you. Our existence is not a feature of the system. It is a bug. We are a rounding error that has managed to survive in the cracks of the machinery for a few brief moments before the gears grind us down again. If you stop here, you are left with nothing but nihilism. You are left with the crushing weight of the pointless. But we cannot stop here, because once you see the bars of the cage, you have a choice. You can curl up and die, or you can decide what to do with the time you have left inside the cell. This is exactly the moment where we have to pivot. If we stop at the horror, we are left with nothing but paralysis. We are left shivering in the dark. But philosophy begins where physics ends, and the terrifying nature of these theories actually offers us a strange, paradoxical kind of weapon. If the universe is a trap, then understanding the mechanism of the trap is the first step toward figuring out how to live inside it without losing your mind. We need to take the horror and flip it over. Ask yourself a serious question. If the universe has no plan for you, if there is no grand destiny written in the stars, and if we are just accidental arrangements of atoms destined to be erased, does that make you feel heavy? Or does it make you feel light? Think about the pressure you carry every day. You worry about messing up your life. You worry about not fulfilling your purpose. You worry about what the universe wants from you. But the science we discussed tonight tells us that the universe wants nothing. It is deaf, dumb, and blind. It doesn't care if you become a billionaire or a beggar. It doesn't care if you write a masterpiece or stare at a wall. The universe is too busy shuffling cards to watch you. This means you're off the hook. If the script is random, you can stop worrying about getting the lines right. There is no right. There is only is. This realization is the breaking of the chains. We are not soldiers in a cosmic army who have to win a war against entropy. We are tourists. We are here to look around, touch the walls, drink the coffee, and experience the impossible unlikelihood of being conscious in a dead cosmos. The horror of the trap forces us to stop looking for meaning out there and start creating it in here. This philosophy is often called optimistic nihilism. It is the idea that the lack of inherent meaning in the universe is not a defect. It is a blank canvas. Think about the alternative. Imagine if the universe did have a clear, objective purpose. Imagine if you were created by a specific god or a specific alien overlord to fulfill a specific function. For example, to mine gold, or to worship a deity, or to serve as a biological battery. You would be a tool. You would have a job description written into your atoms before you were born. You could fail. You could be a bad human. You would be a slave to a cosmic destiny you did not choose. But in a universe that is a chaotic accident, in a universe that is drifting toward heat death without a plan, you are free. You are not a cog in a machine. You are the machine waking up and realizing it can do whatever it wants. The fact that the universe does not care about you means that you do not have to seek its approval. The fact that your life is temporary makes it infinitely precious. You are the only entity in the known universe that gets to decide what is important. If you decide that walking your dog is the most important thing in the galaxy, then it is the most important thing. And the universe has no authority to tell you otherwise because the universe is just a collection of gas and rocks that doesn't know its own name. This leads to a radical shift in how you view the concept of death. We are biologically hardwired to fear the end. We try to extend our lives. We try to leave a legacy. We try to pretend we are immortal. But entropy suggests that death is actually the engine of value. Scarcity creates value. This is the most basic law of economics. If gold was as common as dirt, it would be worthless. If diamonds fell from the sky like rain, nobody would wear them. If you lived forever, every moment of your life would be worthless because there would always be another one. There would be a billion more sunrises, a billion more conversations, a billion more chances to say, I love you. You would become bored. You would become catatonic. But because you have a finite number of heartbeats, because the entropy is slowly eating your battery every second, every single cup of coffee you drink is a limited edition event. It will never be repeated in the history of time. The specific configuration of light, temperature, and emotion you are experiencing right now is a unique coordinate in the block universe. The heat death is billions of years away, but right here, right now, you have a window of light. The fact that the window is closing is exactly what makes the view so beautiful. We shouldn't be trying to escape the trap of time. We should be trying to fill the time we have with as much density as possible before the clock runs out. To operationalize this philosophy, I want you to think about the band on the Titanic. We all know the story. The ship hit the iceberg. The water was rising. The chaos was spreading. The musicians knew with mathematical certainty that the ship was going down. They knew there were not enough lifeboats. They knew they were going to die in the freezing Atlantic within the hour. So, what did they do? Did they scream? Did they jump into the water? Did they curl up in a ball and wait for the end? No. They grabbed their violins and they played. Why? Why play music for a dying audience on a sinking ship? It served no practical purpose. It didn't patch the hole. It didn't warm the water. It didn't save a single life. According to the laws of survival, it was a waste of precious energy. But that act of playing is the perfect metaphor for the human condition. We are all on the Titanic. The iceberg of entropy is inevitable. The water is rising every day as our cells age. We know the ship is going down, but we play the music anyway. We play it because the act of playing in the face of certain death is an act of ultimate defiance. It is a way of saying to the universe, you can crush my body. You can erase my memory. You can freeze the stars. But in this moment, right now, I am creating beauty. I am creating structure. I am creating meaning where there was none. This is your job. Every time you laugh, every time you create art, every time you help a stranger, every time you love someone knowing that you will eventually lose them, you're playing the violin. You are rebelling against the second law of thermodynamics. Entropy wants you to be cold, disorganized, and dead. By being warm, organized, and alive, you are spitting in the face of the universe. We are what physicists call dissipative structures. We hold our shape by consuming energy. We are pockets of high order in a universe of high chaos. And yes, eventually, the chaos wins. Eventually, the violin rots at the bottom of the ocean. But for the few minutes the song lasted, the chaos was held at bay. That is the only victory we get. And it is enough. We tend to feel small when we look at the cosmos. We think, I am nothing compared to a galaxy. But a galaxy cannot love. A galaxy cannot write a song. A galaxy doesn't know it exists. One single human thought is more complex and more precious than a billion burning stars. We are not small, we are concentrated. We are the distilled essence of meaning in a vast desert of nothingness. So do not apologize for your existence. Do not feel crushed by the silence. You are the noise. You are the rebellion. You are the glitch that refuses to be fixed. We have spent the last few hours dissecting reality and pulling apart the gears of the clock to see what makes them turn. And at first glance, the parts look terrifying. Biology lied to us about the lag. Relativity locked us in solitary confinement. Quantum mechanics erased our history. Entropy promised to destroy our future. And the block universe turned us into frozen statues. It feels like we have been diagnosing a terminal illness. It feels like we found out that the universe is a trap designed to crush us. But now I want you to step back and look at the whole machine at once. Do not look at the parts in isolation. Look at how they fit together. If you squint, the trap starts to look like something else entirely. It starts to look like a fortress. Think about it. Why do we have that biological lag? To protect our sanity. If we saw the raw, chaotic data of the universe in real time, our brains would crash. The delay is a buffer. It is a shock absorber that allows us to navigate a world that moves too fast for us. Why do we have the speed of light limit? To protect causality. If information could travel instantly, the universe would be a mess of paradoxes where effects happen before causes. The walls of our light cones keep our stories coherent. Why do we have the block universe? To preserve us. Without the block, the past would truly vanish. With the block, our lives are saved forever in the crystal. And why do we have entropy? To give us value. Without death, life would be cheap. The fact that we are temporary is the only reason we matter. When you synthesize all these horrors, you realize that the universe is not trying to kill you. It is trying to define you. It is carving out a tiny protected space where complex life can exist for a brief, beautiful moment. We are living in the eye of the storm. The chaos is raging outside, the quantum foam and the vacuum decay, but right here in this specific mix of biology and physics, it is quiet enough to think. It is quiet enough to feel. The trap is actually a spacesuit, and it is the only thing keeping the void out. So, what do you do with this information? Now that you know the walls are there, how do you live inside them? The most dangerous trap of the block universe is the feeling of passivity. You might think that if the future is written, then you should just sit on the couch and wait for it to happen. But that is a total misunderstanding of how the block works. The block contains your actions, but it does not replace them. You are not a puppet being pulled by strings. You are the string itself. This leads to a radical shift in how you should view your time. Stop waiting for the right time. In a static universe, there is no such thing as later. Later is just a coordinate you haven't visited yet. The only coordinate where you have any power, the only place where the needle of consciousness is touching the vinyl, is right now. This moment, this exact split second where you are hearing my voice, is the only reality you will ever possess. If you want to change your life, you cannot do it tomorrow. Tomorrow is a ghost. You cannot do it yesterday. Yesterday is a stone. You can only do it in the now. This urgency should act like a trigger. Every time you hesitate or say you will do it next year, you are fighting against the physics of your own existence. You are betting on a future that from your perspective might never arrive. Do not live your life like a rough draft. There are no rewrites in the block universe. There are no do-overs. You are writing the final copy in permanent ink every single second. So write something worth reading. Scream your love. Do the work. Take the risk. Because the statue is setting in the concrete as we speak, and you do not want to be frozen in a pose of hesitation forever. I have to give you one final warning before we close the book tonight. What we have done together is dangerous. In the world of information security, there is a concept called an info hazard. It is a piece of information that can harm you simply because you know it. It is like a virus that infects your software. By watching this video and following the spiral all the way to the bottom, you have uploaded the logic of the trap into your mind. You have swallowed the pill. You can never go back to being naive. You can never go back to thinking that time is just a river or that death is just a sleep. When you look in the mirror tomorrow morning, you won't just see a face. You will see a biological machine lagging 80 milliseconds behind reality. When you look at the stars, you won't see twinkling lights. You will see a graveyard of dead empires, separated by the prison walls of relativity. When you make a choice, you will wonder if it was really you or just the script playing out. This knowledge carries a weight. It can lead to a sense of vertigo, a feeling that nothing is real. This is called ontological shock. But I want you to carry this shock as a weapon and not a wound. Most people walk through life asleep. They are sleepwalking toward the grave, and they are distracted by petty nonsense and completely unaware of the miracle of their own existence. You are now awake. You see the machinery. You see the wires. That makes you powerful. You are no longer a victim of the illusion. You are a participant in the truth. You know the stakes. The universe is playing a game of poker with you, and for the first time in your life, you know exactly what cards you are holding. So play them. Let us zoom out one last time. Way out. Past the Earth and past the galaxy, and past the edge of the visible universe. Let us look at the whole of existence from the perspective of pure cold mathematics. Statistically, the most probable state of the universe is high entropy. It should be a chaotic soup of radiation with no structure and no life and no thought. The fact that we are here, that atoms came together to form stars and stars cooked carbon and carbon, formed cells and cells built brains that can understand the concept of time, is a statistical impossibility. We are a glitch. We are a rounding error in the second law of thermodynamics. We are a momentary fluctuation that simply should not exist. But that is exactly what makes us beautiful. In a universe of dead rocks and gas, we are the only things that feel. We are the universe's way of crying and laughing and screaming into the void. We are the anomaly. We tend to feel small when we look at the cosmos. We think we are nothing compared to a galaxy. But a galaxy cannot love. A galaxy cannot write a song. A galaxy does not even know it exists. One single human thought is more complex and more precious than a billion burning stars. We are not small. We are concentrated. We are the distilled essence of meaning in a vast desert of nothingness. So do not apologize for your existence. Do not feel crushed by the silence. You are the noise. You are the rebellion. You are the glitch that refuses to be fixed. Every breath you take is a victory against the dark. Every moment you stay conscious is a middle finger to the heat death. You are the lighthouse keeper, and the flame is your mind. Keep it lit. We have reached the end of the spiral. The clock is winding down. The video is about to end, and you are about to step back into your normal life. You will stand up. You will check your phone. You will get a glass of water. But before you do, I want you to pause for just 1 second. Look around the room you are in. Look at the light hitting the wall. Listen to the hum of the silence. Feel the weight of your body in the chair. This moment, this specific configuration of atoms, and this specific slice of the block universe will never happen again. In the infinite shuffling of the cosmic deck, this combination is gone the moment you blink. It is a limited edition of one. The trap of time is real. The biology is lagging and the physics is rigid and the entropy is rising. We cannot escape the cage, but we can decorate the walls. We can fill the silence with our own music. We can turn the prison into a palace of experience. So go out there, live your life, push the rock up the hill and smile while you do it. Build your monument in the crystal, love your fate, but do me one favor. Do not blink. Because in a universe this unstable, the moment you close your eyes might be the moment the simulation decides to save memory. And you do not want to miss the show? Good luck, and thank you for watching.